Okay, so for this video, let's talk about how we could use that skill completing the square to solve certain flavors of quadratic equations, okay? And in this video, we're gonna stick to when a equals 1, when there's just 1x squared, and when b is an even number. There's an even number of x's, okay? So for this first example, we have x squared plus 4x equals negative 29. And our directions tell us to solve it. Let me add that in really fast. Sort of implied by the title of this video, but we always need to read directions and follow directions. Okay, so if I want to solve this equation, it is a quadratic equation, and if we tried to solve it by factoring, number one, we'd recognize that this isn't in standard form. It doesn't equal 0 on one side. We'd have to add the 29 over. And then the next thing, and the bigger problem would be, if we tried to factor that, x squared plus 4x plus 29 doesn't factor. There are no factors of 29 that are going to add up to give us positive 4. Okay, so trying to solve this by factoring wouldn't work. But let's see what happens when we apply this skill of completing the square that we talked about in the previous video. Okay, so once again, if I do this in my head, if I take half of that 4, half of positive 4 is positive 2. And then if I square that, positive 2 squared is a positive 4. So if I add 4 to the left-hand side, that left-hand side becomes a trinomial that will then factor very, very, very nicely, okay? But we are working with an equation this time. And so we have to remember our cardinal rule of algebra. I can do whatever I want to one side of the equation, in this case add 4, so long as I do the same exact thing to the other side. So I can't just add 4 to the left without adding 4 to the right as well to keep this legal. All right, so here's where that factoring into a perfect square comes in real handy. If I factor this side next, x squared plus 4x plus 4 factors as x plus 2 times x plus 2, or just x plus 2 squared, equals negative 29 plus 4 is a negative 25. So what made this handy is now this says something squared equals a number. And if something squared equals a number, I can use the square root property to get rid of that squaring, okay? Or in other words, if something squared equals that number, then that squared thing, in this case x plus 2, is going to equal either the positive or the negative square root of that number, in this case negative 25. And this gives me something on the right that I can simplify a little bit. Recall, the square root of a negative number is automatically going to become an imaginary number I. So this is plus or minus I squared to 25. But the square root of 25 also simplifies to just 5. So x plus 2 equals plus or minus 5i. So i's on the prize. I'm trying to solve for x. So with x right here, the only thing I have left to do to solve for x is to get rid of this adding 2. So I'm going to subtract that 2 off of both sides. But when I do, this is very important. I'm going to stick that minus 2 in front of that plus or minus, so that I end up with x equals a negative 2, a minus 2, plus or minus 5i. And that ends up being my solution set. I have two complex solutions. And if you'll recall, that plus or minus means I've got two different expressions there. In one case, we should take the plus. In the other case, we take the minus. But the two solutions are x equals negative 2 plus 5i, and x equals negative 2 minus 5i. But most of us are lazy, and we just leave it right here. I believe your homework may or may not I think it may require you to split it up into the two solutions, but either way, there they are. Okay, so let's recap. What did we do first? Well, the problem kind of started out a little gift wrap for us. It already had the x squared and the x term together for us and the constant on the other side. On the next example, we're going to change that. So then we added the value that completed the square on the left, making sure we add the same exact value on the right side. We factored the left. Then when this said something squared equals a number, we use the square root property. That basically gets rid of that squaring. We simplified the radical, and then we solved for x, and that was our solution. Okay, so let's practice this again. Okay, for this equation, let's solve x squared minus 6x minus 29 equals 0. Okay, once again, if you want to pause the video and try to solve this by factoring, you're welcome to give it a shot, but this is not a trinomial that factors. Okay, so what could be another method that we use? Let's try completing the square again, but this time we're going to have to do an itty-bitty bit of algebra first to set it up. We want to leave our x squared and our x terms together. And notice once again, I have just one x squared and an even number of x's here. We want to leave them together and we want to move the constant term to the other side. So I'm going to add that 29 off both sides. And so when I rewrite this, x squared minus 6x, the next step is going to be complete the square. So I'm going to leave myself a hole, a gap, where I can easily complete the square. And I'm going to bring that 29 over. Sorry, I just had a mental brain farty thingy. Okay, so what is the value that would complete the square on the left? We take half of that minus 6, and we get minus 3. We're holding that number in our head. And then we square it. So the value that we add to complete the square, negative 3 times negative 3 is positive 9. I'm going to add a 9 to the left, but cardinal rule of algebra, whatever I do to the left side, I have to do to the right side. And so then I factor that left side. So when I try to factor x squared minus 6x plus 9, I get x minus 3 times x minus 3, or just x minus 3 squared, equals, on the right side, 29 plus 9 is 38. So now, something squared equals a number. I can use the square root property to get rid of my squaring. So the squared thing, x minus 3, equals either the positive or the negative square root of 38. Am I going to get an I on this one? No, because we're taking the square root of a positive number. So our solutions are going to be real. They're just going to be ugly because the square root of 38 is not a nice number. But we do need to consider, can that be simplified? Does 38 have any perfect square factors like 4, 9, 16, and so on? And if we play on our calculator just a little bit, we divide by 16, nope. We divide by 9, nope. We divide by 4, nope. None of those give me a nice whole number. So lucky us, the square root of 38 simplifies into just the square root of 38. So we focus on next, since this can't be simplified any further, solving for x. So we've got to get rid of subtracting 3, and we're going to do that by adding 3 to both sides, of course. So I add the 3 there, and remember, I always want to stick that in front of the plus or minus. So then x equals positive 3 plus or minus the square root of 38. And that could be our final answer. Or if we're required to split that plus or minus up into separate expressions, one takes the plus, one takes the minus, x could equal 3 plus the square root of 38, which is going to be about 9 point something or another, or x equals 3 minus the square root of 38, which is going to be like negative 3 point something or another, I think. Maybe negative 2 point something or other. It doesn't matter. I don't care. But there they are. Those are our two solutions. Let's do one more example for you to try on your own. Okay, so let's try to solve 0 equals x squared plus 16x plus 44. And let's try to do it using completing the square. And I'll give you a hint that, again, factoring wouldn't work for this quadratic equation. You can try all you like, but it won't work. All right, so I'm gonna have you pause the video and try just what you think the first step is. Hopefully you got that the first step was just to move the constant to the other side, okay? So now that we have the x squared and the x term together, we are going to work on the next step. What would be the value that you have to add to complete the square? Okay, hopefully you added 64 to both sides. And I forgot to tell you to pause the video. Hopefully you caught that cue. But next step, factor that polynomial on the right side and simplify on the left. Go ahead and pause the video. Okay, when it's done and all cleaned up, you should get 20 equals x plus 8 squared. Now, I forgot to point this out on some of the other examples. Remember, this little mental number that we had in our head, that positive 8, that's probably going to reappear right there if you're having trouble factoring it. Okay, just a little tip. Okay, so next step, how do we get rid of the squaring? Pause the video, give it a shot. We use both the positive and the negative square root. It's been a minute since I've mentioned this, so let me remind you guys that there are two solutions when you square something. You need to remember the positive and the negative root in those cases. And if you don't remember the plus or minus, then you've thrown away half your answers. And if you throw away half your answers, then I throw away half your points. You're not going to get anything better than half credit on something where you forgot to use plus or minus. Okay? So there's really only a handful of steps left to finish solving for x. And the next step is not going to be to subtract the 8. We got rid of the squaring, but we ended up with plus or minus the square root of 20. Let's see if that can be simplified. Hint, it can. But pause the video, give it a moment. I don't know if y'all heard my cat meow right there, but I'm going to leave it in case it was. So 20 is not a perfect square, but it does have the perfect square factor of 4. 4 times 5 is 20. And since 20 can be written as the square root of 4 times the square root of 5, and I can simplify the square root of 4 as 2. I'm bringing out that 2 as plus or minus 2 times the square root of 5. That is not a perfect square and doesn't have any perfect square factor, so it has a life sentence there in radical prison. So plus or minus 2 square roots of 5 equals x plus 8. Last step, subtract that 8 over, but when you do, remember, stick it in front of that plus or minus. So we have x equals the minus 8 or the negative 8 plus or minus 2 square roots of 5. That's a perfectly great answer. Or if we're required to split it up, somebody gets a plus, somebody gets a minus. It's like your parents in custody. Oh, that's not a minus. What am I doing? Let me erase that. So weird. One gets the plus, one gets the minus. X could equal negative 8 plus 2 square roots of 5, or x equals negative 8 minus 2 square roots of 5. And voila. All right. One more example for you to try on your own, and then I'm going to call it quits. Try to solve x squared plus 2x plus 3 all by yourself. I'm going to have the full answer worked out as soon as you're unpause the video, just so you can check your work. And if you didn't get the answer that I got or the solutions I got, then I'll work it out as the video goes on. But this is the last thing. So if your answer matches my answer, then you're done. You did it right. High fives and hugs. All right, so pausing the video. Okay, our solution should be -1 plus or minus I square roots of 2, or -1 plus I square roots of 2, and -1 minus I square roots of 2. If you got it, high five. See you later. If not, let's see if we can figure out what went wrong. So what I'm going to do is I'm going to subtract the 3 first from both sides, move my constant term over, leaving my x squared and my x term on the one side. I'm going to leave a gap for me to complete the square. That equals -3. So I'm going to take half of +2 and get +1. And then +1 squared is still +1. So I'm going to add 1, but I'm going to add 1 to both sides. And then when I factor x squared plus 2x plus 1, that factors as x plus 1 times x plus 1, or just x plus 1 squared, equals -2. Square root property, to get rid of the squaring, x plus 1 equals the positive or the negative square root of -2. I can at least pull the negative out and bring out an I. So that simplifies as x plus 1 equals plus or minus I square roots of 2. And then I'm going to subtract the 1 over to solve for x, stick it in front of the plus or minus. And so x equals -1 plus or minus I square roots of 2, like we have up there in the purple. That's it.